Students, today I am going to discuss about the first unit in the second PU physics, that is electrostatics. Okay, you all know physics is the interaction between matter and radiation, and it has so many branches, right? Among all those, this electrostatics is also one of the sub-branch. What we study in this electrostatics, here we study about the electric charges which are at rest, means with forces, fields, potential that are arises due to charges at rest. Properties, phenomena which are arises due to charges at rest. So now in this unit electrostatics, you have two chapters, that is electric charges and fields is the first chapter. And the second chapter is electric potential and capacitors. I am going to discuss about the first chapter, electric charges and field. What are electric charges? What are electric charges? See, the electric charges are the basic property of a matter. So due to that property, that body can attract another body or it can repel the other body. So a property of a matter or a body, due to that property, so it can attract or repel another body will be called as the electric charges. And in this electric charges, there are two types, that is positive charge and negative charge. So, around 600 BC, so the Hayes of Miletus has observed when amber rubbed with the silk cloth, it can attract the lighter objects. So, that means that amber is having some property. That basic property is the electric charge. Not only amber, all the bodies are having this property, means electric charge. So, charge is an invariant property. Then the two types of charges, that is positive charge and negative charge. So conventionally the charge on proton will be considered as a positive charge and charge on electron will be considered as a negative charge. Charge on proton is taken as positive charge, charge on electron is taken as a negative charge. So when do we say a body is a charged body and an uncharged body? Suppose if the total charge of a body is equal to 0. Total charge of a body is equal to 0 means, so if the body has equal number of positive and negative charges, means equal number of protons and electrons, then the net charge means sum of the charges will be equal to 0. So that type of body will be called as a uncharged body, or we can also called as a neutral bodies, uncharged body or a neutral body. So if a body is said to be an uncharged or neutral body, it should have the sum of the charges equal to 0, or net charge of that body will be equal to 0. Example, we can consider an atom as a uncharged body. Atom will be considered as an uncharged body because you all know atom will be having central nucleus, around that electrons are revolving. So inside the nucleus protons are there. So there are, if two protons are there in the central nucleus means, then two electrons are also there in the outermost orbital. So therefore the net charge will becomes equal to 0. Therefore atom will be considered as a neutral or uncharged. In the same way, suppose if the total charge of a body is not equal to 0. Not equal to 0 means sum of the charge will not be equal to 0. Means it may be having either a positive charge or a negative charge. It is having some value on that. So it is having either a positive charge or a negative charge. Therefore the body will be called as a charged body. So the body is said to be a charged body if it has a sum of the charges not equal to 0. If the sum of the charges is not equal to 0, then the body is said to be a charged body. So then we can consider one of the thing, that is how we can distinguish the positive charge and negative charge in a body. In order to differentiate the two types of charges, we use a basic property, and that basic property will be called as a polarity. So the polarity is the basic property. So by using that property, we can differentiate the two types of charges. Means we can separate, we can find the two types of the charges, that is positive and negative charges. So in order to differentiate the types of charges, we use a basic property, and that property will be called as a polarity. So then I have already told all the bodies are having charges, and charge is an invariant. How we know so that body is having charge? So example we can consider. Suppose if you rub two bodies, the electrons will transfer from one body to other body. The body that loses electron becomes positively charged, and the body that gains electron becomes negatively charged. If you rub two bodies, during rubbing process, electrons will transfer from one body to another body. So if electrons transferred means one body will lose its electron, so it becomes positively charged, and one body gains electron, so it becomes negatively charged. So the process, if you add electrons to a body or remove electrons from a body, then the body becomes charged. Example, suppose if you rub a glass rod with silk cloth. If you rub a glass rod with silk cloth, the glass rod loses electron. Means electrons will transfer from glass rod to silk cloth. So glass rod loses electron, so it becomes positively charged, and silk cloth gains electron, so it becomes negatively charged. In the same way, so if you rub cat's skin or cat's fur, skin or fur, so by using or with the ebonite rod. So if you rub ebonite rod with the cat skin or the cat's fur, cat skin or cat's fur loses electron. Means electrons from the cat skin transfer to the ebonite rod. Therefore cat skin becomes positively charged and ebonite rod becomes negatively charged. In the same way, if you rub the woolen cloth with the plastic rod, either plastic rod or rubber or amber. So if you rub woolen cloth with the plastic rod, it will lose its electron, so it becomes positively charged. Therefore, so plastic rod gains electron. Or if you rub with rubber, rubber gains electron. Or if you rub with amber, amber gains electrons. Woolen cloth loses electrons. Therefore, woolen cloth becomes positively charged, and this plastic rod or rubber or amber becomes negatively charged. Now, let me move on to discuss about the next concept, that is conductors and insulators. What are conductors and what are insulators? See, conductors means these are the substance that can pass the charges through them easily. Means if electric charges flow through some type of substances so easily, and those substances are called as the conductors. Example, we can consider all metals. All metals are conductors because they can easily allow the charges to pass through them. So, or earth, human body, animal body, these are all the material, means substances that can easily pass the charges through them. So, these substances are called as conductor. And in the case of conductors, the charges are distributed uniformly on the surface. If you consider the conductors, the charges are uniformly distributed on the surface. Either a negatively charged conductor or a positively charged conductor, the charges is uniformly distributed on the surface of the conductors. So then insulators. What are insulators? Insulators are also the substances. But they do not allow the charges to pass through them easily. So they cannot allow the charges to pass through them easily. So example for insulators are wood, plastic, or rubber, diamond, like this. All non-metals are the examples of insulators. In the case of insulators, so the charges are resides at the point where you have put them. Means, so if you are rubbing this part of the insulator with another, so then charges will reside at this point only. In the case of insulator, charges cannot be distributed on the surface. They stays at the same place where you have put either a positively charged insulator or a negatively charged insulator. The charges resides at the same place where you have put them. So this is about the insulator. Now, let me move on to discuss about the next concept, that is earthing. What is mean by earthing? Earthing means what? Earthing means it is the sharing of electrons with the earth. Sharing of electrons with the earth will be called as earthing. Sharing of electrons with earth means how the electrons will be shared with the earth. Suppose if you consider a positively charged conductor. Let us consider a positively charged conductor, and if you connect this positively charged conductor to earth, earthing or grounding, we call it as a grounding or earthing. It will be represented by this symbol. So, if you connect a positively charged conductor to the ground, the electrons will flow from earth to this body, so that until this body becomes neutral. Okay. So, electrons from the ground will transfer to this conductor, means electrons will flow from the earth to the body, so until this body becomes neutral. In the same way, suppose if you connect a negatively charged conductor to the earth, negatively charged conductor to the earth, here negatively charged conductor means electrons are there in the body. While charging a body, only electrons will move. So, the electrons from the body will move to the earth until the body becomes neutral. Okay. Suppose if you connect an uncharged conductor to the earth, then this conductor is already in neutral condition. So, there is no transfer of electrons between the earth and the conductor. Did you got this thing? So, earthing means sharing of electrons or sharing of charges with the earth. So, then if you connect positively charged body, electrons will move towards this conductor in order to make it neutral. And so, if you connect a negatively charged conductor to the earth, electrons will flow from the conductor to the earth to make it as neutral. If you connect a neutral body, there is no sharing of electrons because the body itself is in neutral condition. Okay. So, why this earthing is necessary? What is the need of earthing? See, we all know, so from mains to our houses, the electricity or current will be carried by 3 core wires, that is live wire and neutral wire and so ground. I mean in our home or houses, so the current will be carried by 3 wires, that is live, neutral and ground. So this live wire is represented by, it is in red color wire, okay, and the neutral wire is black in color and ground wire is green in color. So why this earthing is necessary for homes? See, in order to take care of our electrical appliances like TV, refrigerator, like this. So in order to, for a safety, the earthing is necessary as a safety measure in for home appliances. So how it is? It acts as a safety measure for our home appliances. See, earthing means here the live wire, we know live wire and neutral wire will carry the current from mains, right? See, here this earth wire means having two ends, so one end of the earth wire is connected to a thick metallic plate. After connecting that earth wire, one end of the earth wire to a thick metallic plate, that metallic plate is buried in the earth, okay, and the other end is connected to the metallic bodies of our home appliances, okay. So then, when suppose in case if the live wire touches the metallic, then immediately the excess charges from the metallic body will flow to the earth through the earth wire. Therefore, our home appliances becomes safe. So this earthing will be, it is a need, it is of very much need, as a safety measure in home appliances. Now let me move on to discuss about the next one, that is electroscope. See, this electroscope is a device that is used to detect the charge in a body. Is there any charge in the body or not? To find this, we use a device, electroscope. So then, gold leaf electroscope is one of the common type of the electroscope. So this gold leaf electroscope is used to detect the presence of charge in a body. Is this body having charge or not? To find, so we use this electroscope. So how this gold leaf electroscope is constructed? So this gold leaf electroscope is consisting of a metallic rod. It is consisting of a metallic rod. So and one end, upper end of the metallic rod is consisting of a metal knob, means metallic knob, and lower end of the metallic rod is fixed to the gold leaves. Gold leaf electroscope consisting of a metallic rod. So it is kept on a box and one end is fixed with the, it is consisting of a metallic knob, and the other end is consisting of, or it is fixed to the gold leaves. These are the gold leaves. Okay. So then, when a charged body, so here I have taken a glass rod, charged glass rod. When a charged body touches this metal knob of the metallic rod, the charges are, since it is a metal, it can easily pass the charges, right? So the charges will pass through this metal rod and they pass through this gold leaves. So the gold leaves are like this. So these are like this. Okay. When charges pass through this rod to this gold leaves, so the leaves of gold will diverge. Why they diverge? So positive charges are passes and deposited, so in both the leaves. Therefore, so here if the two charges, two charged bodies which are charged with the same kind repel each other. Okay. Therefore, these gold leaves are diverged. So this divergence of gold leaves shows the presence of charge in that body. This way we can detect the charge in a body. This is about the gold leaf electroscope. Okay.